Welcome to EGME-333 Fluid Mechanics. This video will discuss the definition of a fluid. So let's begin by asking the simple question of what is a fluid? You might think of water, which is a liquid, or air, which is a gas. Note that in these two cases, these are examples of fluids, but they do not necessarily define what a fluid is. So to better define what a fluid is, let's focus on the mechanical behavior of a fluid by first considering a rectangular element of a substance, which we'll label A, B, C, and D, where its base, CD, is fixed. And to understand a fluid, we'll compare the behavior of a solid with that of a fluid. But first, we'll focus on the mechanical behavior of a solid. Now consider a lateral shear force that is applied to the top of the substance ABCD. The natural question arises is then what happens to the shape of substance ABCD? From solid mechanics, you can infer that the solid will deform to a new shape, A prime, B prime, CD. So in essence, this substance, when we apply a lateral shear force, it will experience a finite level of deformation, which we can quantify with the Greek letter theta. So the idea is then that the shear stress produces a proportional deformation angle or shear strain theta, such that the shear stress is linearly proportional to the deformation theta. So let's now visit a fluid and see what happens to a fluid element when we are subjected to the same load scenario. So again, we'll take the fluid element ABCD and we'll apply a lateral shear force on the top of the fluid element. Again, we'll ask the question, what happens to the shape ABCD? Just like with the solid, the fluid will experience some form of deformation. However, this deformation will continue as long as the force is applied. So the idea then is when we're looking at the mechanical behavior of a fluid, we are more concerned with how fast the fluid element deforms, as indicated by the angle theta dot, versus how much the fluid element deforms, which was the case when we were talking about the solid element. So we can say that the shear stress is proportional to the deformation rate or shear strain rate theta dot. With this in mind, we propose the following definition of a fluid, which states that a fluid is a substance that deforms continuously under the application of a shear stress, no matter how small the shear stress may be. Alternatively, we can interpret the definition of a fluid as a substance that cannot sustain a shear stress by static deformation.